There are many techniques that can be used for cluster analysis. One of the most popular is kMeans cluster analysis, and in this video, I'll show you how it works. With kMeans clustering, the goal, as with any cluster analysis, is to take a set of data points and divide them into groups or clusters. With k-means cluster analysis, the data is divided into k clusters, and k is the number of clusters that you want. In this example, the analyst wants 3 clusters, so that would be 3 means. If you wanted 4 clusters, it would be 4 means. 4 represents the k. There's a basic procedure which goes step by step, and I'm going to step through these with a little demonstration of how the k-means algorithm works. You begin with a data set like this, and let's suppose we want 3 clusters. So one of the things in k-means cluster analysis is that the analyst needs to determine in advance how many clusters they want. In this case, let's do 3. And just think of this right here and consider how would you group those data points into 3 clusters where the members of the clusters are closer to each other or more similar to each other, whereas those that are farther apart are less similar to members of other clusters. And here it will be the ones that are closer are together. What would you classify the 3 clusters to be? We're going to associate the clusters with colors and shapes. So we're going to have a green triangle cluster, a blue square cluster, and a red diamond cluster. The first step of k-means cluster analysis is to initiate what are called centroids. And a centroid is a space, a point in space, that is the center of all the members of the clusters. So to begin, k-means cluster analysis just takes 3 random points. It can be any point, any space here. So not existing points, but just 3 places in this space, and says those are the centers of the clusters. That's where it starts out with. And in this random analysis, these are the 3 centers where it begins with. And that's the first step. So once the centroids are set, step 2 involves assigning each data point to the closest centroid to it. And that is initial assignment of the clusters. So for instance, this one is closest to green, you put it there. These are closest to green, you put them there. You can see them there. You're colored based on the closest ones. This one here is closest to blue, these are closest to red, and so on. Some that are a little bit farther away are a little bit hard to tell. Like, do these ones here go to the green or to the blue? And the way the closeness is determined is based on some kind of distance measure. The most common way to calculate distance is called the Euclidean distance, and that's on a 2-axis plane like this. It's just a straight line. That's what the Euclidean distance represents. But there are other ways to measure distance for cluster analysis. And so based on that calculation, each of these points is assigned its cluster based on the centroid to which it's closest. So that's step 2. Now, when you look at these, this doesn't necessarily look like a very satisfactory cluster solution, but we're just getting started. In step 3, based on these first draft clusters, you now move the centroids to be at the center of all the members of the cluster that has been initially set. So this green moves over here, the blue moves around there, and the red moves around there. And the center position for the new centroids is calculated using the sum of squared errors, and you minimize that. So there's a mathematical equation there, but visually you can see what's going on. You just move it to the center of what are now of the first draft clusters. However, once you've moved the centroids, then suddenly the closest centroid to each point might not necessarily be the same. So you can see right here that this green is no longer closest to the green centroid, but since the blue centroid moved up, it's now closer to the blue. So in step 4, once you move the centroids, you have to recalculate for every single member which centroid is now the closest. And with that, you can see that there's certain points that change cluster membership. So like here, this one was green, but now it's closer to blue, so it changes color. This one here was initially blue, but now it's closer to the green, so it changes color. And this red one, that's a hard one to tell, but just using the straight line distance, the Euclidean distance, it's no longer closest to the red, it's now closer to the blue, so that changes distance. Then whenever you change membership, you have to recalculate the centroids and shift the centroid to the center of what you now have. And so when you've moved this, you keep on repeating this, recalculating centroids, shifting the membership, recalculating centroids until you come to a point where, after your last change, the centroids don't move any longer. Or if it's a very large data set, you might reach a point where, well, maybe they move because it's taking such a long time. They don't move significantly. But in this small data sets, when the centroids don't move any longer, so there's no new change in cluster membership, you're done. And now this is a solution that the algorithm has given us with the centroid memberships. Here are the clusters based on the closest of what we have. And that's basically how k-means cluster analysis works.